In this video, I'm going to cover mass spectrometry, sort of not in super large detail, but just in the context of what you need to know for AP chemistry, and maybe a little bit beyond, but nothing too crazy. So we have a picture here of basically how a mass spectrometer works, which is a piece of lab equipment. Okay, credit to Khan Academy for the picture. So how this works is you have a sample of an element. Sometimes people will put compounds into it, but we're only going to, in AP chemistry, you only need to analyze mass spectrums of individual elements. So if we have a sample of an element, basically it gets ionized. Okay, so we see an electron beam source. And so that causes the atoms in the elements to get ionized. Typically they'll end up with a +1 charge. Okay, in theory they could have other charges, but for our purposes we're just going to consider ions that result in a +1 charge. Okay, and then so the ions, they sort of are propelled forward and then they encounter this magnetic field, and a magnetic field causes a moving charge to experience a force that causes it to like deflect. Okay, and the more charge it has, the more it's going to deflect. So like this one here could have more charge, but again, we're really considering stuff that all has the same charge. We're considering all +1 ions. So the other factor is the mass. Okay, so the mass, more mass, it's going to be deflected less because it has more inertia. It wants to keep moving in a straight line. So here, the one that's deflected the least is going to be the one with the greatest mass. Now, and then the one that's deflected the most with the smallest mass. Now, if we really want to be general about it, it's really the mass to charge ratio, because again, how much it deflects depends on mass and charge. So really the one that deflects the least has the largest mass to charge ratio, and the one that deflects the most has the smallest mass to charge ratio. But again, we're just considering, in AP chemistry, we're just going to be considering things with +1 charges. So we're just focused on the mass. And really, you don't even need to worry too much about how the intricacies of this work. That's just sort of if you're interested. But really what you're going to need to do with this is when this device sort of detects this, it spits out a graph based on how like intense each of these things are. We can get an idea of like what percentage of the atoms are each of these mass to charge ratios, or just masses if we're talking about +1 ions. So it's going to spit out something like this, and this is actually not fully complete. So I'll show you how to complete it. Okay, so this is an example of what you're going to need to sort of know regarding mass spectrometry. This is actually part of a free response question from the 2025 AP Chemistry exam. Now, they haven't given us the complete mass spectrum here, but what we see is we have mass on the x-axis and relative abundance on the y-axis. Okay, this is in percent from 0 to 100. Right now, there's a line, or sometimes we call it like a peak at 24 that goes up to almost 80%. And it tells us that the percent abundance of magnesium 24 is 79%. So that's corresponding to that line or peak. Remember, when it's written like magnesium 24, that means that 24 is the mass number. And then it says the percent abundances of the other two natural isotopes of magnesium, magnesium 25, magnesium 26, are approximately equal. Well, so that means that the remaining is 100 minus 79. So that's 21. And then we're assuming they're equal, so we're splitting that into 2. So they would each be 10.5%. So then to show that, that would look something like this. So that would be the mass spectrum of magnesium. And sometimes in the question, they might give you the full mass spectrum and then ask you some question about it. Okay, but that's basically the extent of what you need to know for AP chemistry. And again, notice that they're not even calling this mass to charge ratio. That's really what the mass spectrum measures. But if they're all +1 charges, then the mass to charge ratio will just be the same as the mass. And that's what it assumes for AP chemistry. So you don't need to really worry about that detail. And then look at this other question. Describe the difference in atomic structure that accounts for the difference in mass between magnesium-25 and magnesium-26. Well, these are isotopes, same element with different mass numbers. So that means they must have different neutrons, different number of neutrons. Specifically, if we look at the periodic table, we see that magnesium has an atomic number of 12. So magnesium-25 is going to have 13 neutrons, and magnesium-26 is going to have 14 neutrons.